Welcome to this tutorial, Video Game Programming and Graphics Fundamentals. In this tutorial, I will try to explain to you what are the basic ideas behind a video game, what are the building blocks of a video game, and some fundamental things that you need to know to understand how graphics works, especially when we're talking about interactive graphics, where is the user that changes what is happening. We will be developing a very simple video game that you can see here, where there is a spaceship that you can control with your keyboard, and there is a little red ball that bounces and of course bounce back if hit by the spaceship. Let's get started. We will be using this file, index.html, and you can access the demo at this website here that it's linked in the GitHub repository. Let's open this file and see what's in the code. Everything was developed in JavaScript just because it is in some ways easier in my opinion to understand some ideas because there is all this HTML file with canvases, etc. That makes everything easier, so it can run on a web browser and you do not need to compile anything, because the main ideas that I want to deliver with this tutorial are what are the essential parts of a video game and how graphics works in rendering images and things like that. So in my opinion, this was the best choice, even if I do not recommend using JavaScript to develop video games unless you're using very powerful libraries or dedicated libraries, like for instance GDevelop. But using pure JavaScript is not a wise idea for a series of reasons. There are the reasons that I'm going to to explain throughout the tutorial. So the first thing is colors and how images are represented on a computer. Uh, this is a very basic idea, but it's important to understand that everything in a computer is made up of numbers, like images, of course. Here I have defined this mapping where we have very few colors, but are sufficient to display this video game that you saw here. This is important in a way because in the following lines in the code you will see how images are represented, but that is not actually the real way things are represented in the memory, and I will explain to you the details later on. But it's important to understand that in the end everything is made up of pixels and little dots, the little dots that you can see on your display if you look at very closely. Let's talk about graphics, and the graphic card that you have in your computer is a dedicated piece of hardware that it's meant to process graphics, of course. But one important thing that you must understand is that everything that it's useful for a video game to run must reside in memory. So the general idea is that your graphic card both has a dedicated processing unit and a dedicated memory. And in this memory, you have the frames of your video game. The memory holds the frame of your video game, but also all the other things that you need, like textures, characters, and all the other things that you might need, so that the processing unit has a way to access to those things that it needs to redraw essentially what happens in your world. Because one thing that you must understand when developing video games is that you are creating basically something unpredictable, because it is the user that decides whether he wants to go to the right or to the left. So the graphical processing unit must be able to recalculate everything on the fly and create the frames as fast as possible so that the animation is as fluid as possible. For the sake of this tutorial, we will be working with just 2 frames. That this is not the reality, of course, but it is enough to understand how things work, because we will have frame 0 and frame 1. Frame 1 is where the central graphic processing unit is going to store everything as it calculates the new positions, the new pixels that it has to turn on and off. And once that frame is ready, will be moved to frame 0, and then it's frame 0 that it's displayed on your screen. This is important to understand because you can easily imagine how it would be uh, bad for a video game if images are redrawn over and over again on the same page. And in fact, this is how things work basically. I mean, it's an oversimplification, but this is to give you the idea. background is a variable that in a way represents a texture. And this is again something that must be there stored in the memory so that it is as quick as possible to just retrieve this image and to display it on the screen. And in fact, we will use the background and we will have to redraw the background once we have the frame ready. And in this way, we do not have to recalculate the background every time, as you will see in the following line. As I have anticipated before, images are represented as pixels, but usually they are rendered with primitives, because in this case we are just talking about little balls, stars, etc. But once, when you have things that are complicated and like, for instance, I don't know, a car or something three-dimensional, usually images are stored as primitives and not as matrices. But this is just to show you what is the final result of everything. You end up with a matrix, but you can easily understand that if I store something as a matrix of points and I try to enlarge it, the result is like enlarging a photo. It's not a good result. But if I store images as primitives, of course I can draw these primitives as large as I want without any problem in the resolution. So here is the first matrix that we have, that is the little star that we see here in the sky. And it's just defined as a series of zeros and one. And here are the colors that I was mentioning at the very beginning. Then we have other sprites that are basically the things that move in a video game that are defined again as matrices. But we also have other properties. If we were using a real programming language, sorry for saying real programming language, but it would be C++ because JavaScript is, of course, a web programming language. This it would be a lot different because we will be representing sprites as objects with their behaviors, but basically this is the same idea. We have these variables that define where the ball is, so we have x and y, plus we have two vectors, like in physics, that define where the ball is moving. So we have both a sign and a magnitude. It just tells us how fast the ball is moving and where it is going. The same goes with the spaceship. We have a matrix that defines how the shape and the color of our spaceship, but we also have coordinates and again the vectors. So this is everything that we need to have in memory, and let's pretend that our graphic card has this stuff stored in memory and it can recall it very quickly. But now we want to process these images because, as I was saying at the very beginning, we need to understand how the graphical processing unit and in reality the entire graphic card is actually working. The first thing is to draw one point. That point is nothing but turning on one pixel on the screen. As I said before, here we're working with JavaScript, so this solution is not really a good solution, but it only has to represent what happens when I wanted to turn on one pixel. So just ignore how it is done because this is a little too complicated. Actually, things can be a lot better than this, especially if you're using, again, C++ or other real programming languages where you can access the memory, both the memory of the computer and the memory card. But this is to give you an idea on how you can turn on one pixel. Then we have a function that it's used to draw a frame on a canvas. The canvas is basically our display, our box here. So we are basically copying one frame onto the canvas. As I said at the very beginning, we want our frame to be ready when we start to copy this on the screen. So this is basically what it does. Again, it's JavaScript. It's just for this tutorial. It's not computationally optimized, but this is how things work. It's just a copy of the frame onto the screen. Then we have a copy frame because also in this case, it's not the best thing to do computationally speaking, but this is to give you an idea. And this is we will be using this function to copy frame 1 in frame 0. So only when frame 1 is over, is completely drawn, everything is in the right position, the ball, the spaceship, and the stars, everything is ready. At that point, we move it to frame 0 so that another process can take frame 0 and represent it on the screen. We are doing this because I believe you can easily understand that if we would display the image as we draw it, things will start appearing a little at a time, and that wouldn't be the best way to do, especially if we're working with very heavy computer games with shadows, lights, and stuff like that. So we want to prepare everything on frame 1, and once frame 1 is ready, we move frame 1 on frame 0, and frame 0 goes to the video. And in fact, we need a function that can draw one sprite that can either be the ship or the ball onto one frame. And this is the function defined on line 91. Finally, here we have a function that simply takes frame 0 and copies it on a context, that is the canvas or the display or whatever. So this is actually the display step. So this is the key point. This is the function that is going to pull or over and over again frame 0 and draw frame 0 without doing anything else. And that's why frame 0 must be ready when the process tries to copy frame 0 on the screen. Here we have some helping function. Here in line 104, it's just a random generator. And then we have a function on line 109 where we are basically simulating a controller. A controller is the thing that you use to move your main character. It can either be the mouse, the keyboard, or a controller. And in that case, something happens. It's an event-driven programming that it's, of course, not we're going to see here. I'm not going to explain the details, but what happens is that you wanted to bind some kind of listener to some kind of event so that when that event is triggered, that listener can start doing something. And in fact, this is what happens here. If a key is pressed, we will see at the very end of the code how we can do this. If a key is pressed, we want to change the direction vector of the spaceship for instance, to go from right to left or left to right. This is basically what we will be doing with our controller. And this is basically everything that's going to represent the hardware side of developing a video game, if you allow me to put it like this. Now we will be talking about what are the building blocks of a video game. Every video game has a starting step where things are initialized. Characters, backgrounds, light, and everything else. Everything must be initialized and has to be stored in memory. For the sake of this tutorial, we will create a sky full of stars, and we will create our texture basically. That is the sky that I said before, that will be in memory and loaded from the memory. We will recall it every time we need. And the same usually goes with other things that in our case are not there, but basically it's like the matrices that we defined before. It's just this. We take 10 random numbers and we draw something, the star, on the background. So this background is completely memory. Still, we haven't drawn anything on the screen. Another important step is the clock ticking, because we want something that happens in time. There must be a process that checks everything that has changed in time so that we can basically move the ball or move the spaceship according to what is happening. And in pretty much most of the times in video games, you will find this function that it's run over and over again in background and updates the position of everything else. And in fact, this is what is happening. And once everything is ready, it's drawn now on the frame. And when the frame is ready, the frame will be moved on the display frame and the display frame on the screen. And in fact, this is what happens. Here we start copying our texture, the background, in the frame that we will be working on. So still nothing is happening, and if something is happening, the process that pulls the frame 0 and displays it on the screen, if that thing is happening, we don't care about it because we are working on another area of the memory. So we are working on frame 1. We want to update the position of the spaceship and draw the spaceship. But here is the first interesting thing about developing video games, because you want things to obey to some rules. Most of the times it's pure physics, but you can do whatever you want. But in this case, it's very, very simple. We just don't want the spaceship to go outside of the box that we defined. So if the x exceeds the maximum width or it goes to negative, we want to move the spaceship back. And so as you can see, it bounces back so that it never goes outside. But this is crucial because you can understand that if you do not control everything in a video game, unpredictable things may happen. So it is important to define all these rules of the physics of your world. And the same thing goes for the ball. Here we have all the other things that we need to update for the ball. There are basically the same thing as the the spaceship before. So we are just checking that the ball doesn't go outside the box. But in particular, we are simulating in a way, allow me to abuse of the word physics, but the physics of a bouncing ball. So we wanted to change the direction vector as the ball hits an obstacle, in particular the square where the ball is bouncing. We are simulating a perfect bouncing, so we want the ball just to bounce 45 degrees, but that's an oversimplification, but this is basically what happens. We change the sign of the direction vector as the ball hits one of the walls, and we draw the ball. Now, here we have a function called collision. Collisions are another very important step in video game programming, because not only we want to let things move around and go around and respect physics, etc., but we also want them to have some kind of interaction. And that interaction is usually called collision, but it can be called whatever you want. It's just finding a way for things to interact, because you can understand that in this case, if I do not use collision, the ball would just bounce around without hitting anything else but the walls. But we want our ball to bounce back if it hits the spaceship. And this is basically what we are going to do. We want to see if the two things collide. The two things collide, of course, if they overlap. This is very simple. So we are just taking the coordinates of the ball and the spaceship, and we see if the bounding boxes of those two sprites just overlap. And if they overlap, we are going just to change the sign of the y vector of the bouncing ball so that it bounces back. And this is basically everything. So we need to, just to recap, we need to draw things. We need to define some rules. There are the rules, for instance, of physics. Not only do we need to define how things move, but also how we interact one another. So we need collision. We have a function that it's run over and over again and creates the various frames. In fact, the very last step is this one, where we take frame 1 that it's completely ready and completely drawn at the end of all these steps, and only at this point we will be copying frame 1 onto frame 0 so that frame 0 can be drawn without any problem. And this is pretty much all. But before closing up this tutorial, we need another little step that, if you remember, I have anticipated before when we talked about controllers, because now we need to define a listener, another very important thing, because at this point there is no interaction whatsoever. So we need to have something that it's there that listens what happens. So here we have defined these listeners. Of course, these things are not necessarily defined in this way because we're using JavaScript, but this is just to give you an idea of what is happening. There is something that it's there and listening to what happens. And this is another important thing, because video games, unlike any other thing, like for instance a movie or a static picture, are interactive, so there must be some kind of listener. And this is how you define listeners in JavaScript, but this is of course not the only way to do. Again, if you're using other advanced engines like Unreal or Unity or whatever, it's of course completely different and maybe easier and more powerful than this, but this is the general idea. The final step are these two lines, that these are the best approximation that you can think of when you want to do something like that with JavaScript. Here we have init world, that it's nothing but creating the background and the stars. As I said at the very beginning, we need to have an initialization step. And finally, we have these two variables that define the two main processes that we have running over and over again. One is the graph memory where everything happens, the calculation where the ball bounces and everything, but nothing is displayed. So that is basically what happens on your memory card, on your graphic card. So the GPU accesses the memory, and the things in memory are drawn into frames, and once the frame is ready, will be displayed by this other process here, monitor, that it's set to another interval. I use the word process even if in JavaScript they are not actual processes, but this is an oversimplification because due to JavaScript limitation, it's not really possible to run things in parallel. I mean, you can use other libraries, but this is basic JavaScript, so you can easily understand what is going on here. But this is an approximation, of course. We're focusing on building blocks and basic concepts of video games and graphics. So this is enough to explain how things work under the hood. And again, as I have said many times throughout this tutorial, you can use, of course, other libraries, other things, but I believe that this is an interesting introduction to understand some of the theoretical aspects of how interactive, allow me to call it like this. I mean, they are video games, but they are interactive world or interactive graphics or whatever, how graphics is worked, is drawn and processed in real time by your graphic card. I hope you enjoyed this tutorial, and I thank you very much for your attention if you got to this point.